Alright, this is worksheet 4.2, the cards that were done in class. And in this video I'm going to talk about cards number 2, 4, and 6, solving systems of equations. So looking at card number 2, we have a system of equations here that are both in the format ax plus by equals c, and the variables are lining up here. So elimination is a good method to solve this since our variables are already lined up. However, we do need to make sure that one of the variables ends up canceling out when we combine the two equations together. So it's up to you to choose which variable to cancel. For example, if you wanted to cancel the x's, the least common multiple of 7 and negative 5 is 35. So I'm going to go ahead and multiply this entire equation by 5 and this entire equation by 7. That's going to make this turn into a 35x. That's going to make this turn into a negative 35x, and then they'll cancel out. One thing to keep in mind is when you're multiplying the equation by 5, you're multiplying both sides of the equation by 5. So that will give us 35x minus 60y equals negative 110. When you multiply this equation by 7, you need to multiply both the left and the right side by 7. So that's negative 35x plus 56y equals 98. Now when we combine these equations or add them together, the x's cancel out, the y's add up to negative 4y equals negative 12. That gives us a y of positive 3. The solution to this system is a point, so we still need to find the x coordinate of the point by taking the y value 3 and plugging it back into either of these original equations. Choose whichever one you want and you should get the same answer either way. So I'm going to choose the first one, 7x minus 12y equals negative 22. That gives me 7x minus 36 equals negative 22. Add 36 to both sides, 7x equals 14, x equals 2. So the solution to this system is the point 2, 3. Okay, in card number 4, we have another system of equations, and notice the difference between this one and number 2. Here, the y value is isolated on both the first and the second equation. We can use what we call substitution, or in this case we can call it equal values method, where we're setting both of these equal to each other because they're both equivalent to y. So I'm going to say 5x minus 35 is equal to negative 3x minus 3. And then I'm going to solve this equation for x. So that gives me 8x equals 32, or x equals 4. And then I can take that x value and plug it back into either of these to find my y value. So y equals 5x minus 35. 20 minus 35 is negative 15. So my final answer here, the point of intersection is at 4, negative 15. Okay, going to number 6, here we have some fractions. So one thing you could do if you don't like working with fractions is just try to get rid of all the fractions before you do anything else. So looking at this first equation, let's think about what can we do to this equation to get rid of all the fractions. We have a common denominator here of 2. Here the denominator is 1. If we can get rid of these two 2's, then we'll be able to write this without fractions. So if I can multiply the whole equation by 2, let's see what that gives us. This would give us 10 over 2, which is 5. 2 times 1/2 is 1, so negative 1y, equals 2 times negative 4 is negative 8. The second equation also has a denominator of 2 here. I'm going to multiply this equation by 2 as well to get rid of this denominator here. 2 times 1/2 is 1. 2 times 1/2 x, again, that's just equal to 1. And then 2 times 2 is 4. So now I have a system of equations that's equivalent to this system, except now there's no fractions. In this system, we have a y that's isolated here, y equals x plus 4. In this system, it would be easy to use substitution. So I'm going to substitute x plus 4 into the y in this equation.
Attention students, Jezebel Rubalcaba, please report to the guidance office. Jezebel Rubalcaba, please report to the guidance office.
Okay, so I took x plus 4, substituted in here where the y is. Now I have an equation with just x that I can solve. So this equation, if I distribute this negative, becomes this. Combining like terms, that gives me 4x equals negative 4, or x equals negative 1. And we can plug this x value back in anywhere where we have an x and a y. So figure out what the easiest equation to use would be. I think this equation would be easiest to plug into. Y equals x plus 4, which is equal to 3. So my solution here is x is negative 1, y is 3.